of feedback, of some responses that had many documents attached and some very brief. So this year we came up with a new approach, a new submission spreadsheet checklist form, and it's derived from the long tradition of the National Committee on the Environment Top 10 Awards. And it's also related to the National AIA Framework for Design Excellence. And they use the same 10 measures for a way to evaluate environmental responsiveness. It's loosely related to the AIA 2030 commitment, but not directly, although I think that may get more interconnected as we move ahead. There are extensive resources that we simplified into the checklist that everyone who submitted used. We had a how-to column. We had selected measurable impacts and information you could submit, you could use for each of the categories, the measures. And the 10 measures, just briefly, are basically integrated design, equitable communities, ecology, water conservation, economical construction, energy savings, well-being, resources, materials, change and resiliency, discovery, and lessons learned as part of that. Now, this year, AIA National has revised the framework and some of the nomenclature and some of the guidelines, but it's pretty much the same general direction, very similar. So each of the design awards used the new form to describe how their projects were designed and in response to the measures, and to give a general idea of how well they perform. So the chart that comes with it, the terrific little blue bars that we like so much, is not so much a score or a final number, but it's a graphic to see generally how it's performed. And that became a guide for the awards jury to help them look at the work and help make their selections. And tonight we'll hear from these two terrific projects. Also, the similar process was used for AIA Pennsylvania, the same checklist, and as a standalone award, which was very successful at the state level. And AIA Pittsburgh is undertaking an AIA 2030 commitment education program, and they'll be implementing the framework next year for their projects. So, and as David hinted, it's become a nationwide AIA awards framework as we move forward. And we're finding that the framework for design excellence is a really good tool for using in the office as a way to discuss the designs that we're working on and how well they're responding to these really important guides for looking at our impacts. So with that, turn it back to David.
Thank you, Sherman. Yeah, so this year, AIA National asked all of the big SIBs, all the AIA chapters that have, I think, 1,000 members or more, to sign on and agree to bring the framework for design excellence from the Committee on the Environment to their awards program by 2021. So we got it done this year and got it, propagated out across the state. So major accomplishment, and couldn't have done it without Jonathan and Sherman really shepherding this along the way and making themselves available to walk members through this as they were pulling together their awards submissions for this year. And we also had a deeper embedment of sustainable design reviewers as well as part of this effort. Also, I don't know if you had mentioned that, Sherman, but anyway, so if you guys hold all the way to the end, we're going to do a little plug for some things on the 2030 commitment and policy and advocacy. If you're just joining us, please enter your name, email, and your AIA number into the chat so that we can make sure that you get your continuing education credits for tonight. We're recording this session. We'll make that available to everyone afterwards. But with that, I'm going to pass it over to our first presenter. So John and Philip, I will stop sharing my screen and let you share yours. And if you have any questions along the way, so we're going to spend about half an hour per project running through, and we'll do a little Q&A towards the end. So if you have any questions while they're presenting, just enter that into the chat box.
All right, David, thank you. I am going to share my screen here. Just let me know, David, if you would, when you can see the screen.
There we go.
Perfect. All right. Well, thank you everyone for giving us the chance to present to you all. This is our LG North American headquarters project. We just completed this project in the springtime, just as we were getting into the throes of COVID, which was interesting. So we haven't really had a chance to see the building fully occupied. But we have had a chance to see it completed. This is a project. Oh, by the way, I should mention, Phil Luce, who David had mentioned and introduced, is joining us. He was the project architect on this project, really saw a lot of its development from documentation through CA. I was the project designer on the project. I should also say we've roped in Brian Smiley into this, so he knows the project quite well, and between the both of them, I think they'll correct the record if I go astray at all. So carrying on here, this project started 10 years ago in 2010, and it was really an effort by LG to consolidate a whole lot of office space that they were leasing throughout northern New Jersey and broadly throughout the region, to bring all of these employees under one roof onto what would become a consolidated campus for about 1,500 people or so. So it started with the purchase of a property in northern New Jersey. I'll show you a little bit of detail on that in a bit. They put on a design competition. We won the competition, and I think it was due to a couple of factors. We did have quite a bit of experience in this type of project. This was just coming off the heels of our Canon headquarters in Melville, out on Long Island. But at the same time, I'd like to think that this response was something that was sensitive to place, something sensitive to the environment and ecology of the place, and it was really in keeping and consistent with the values that LG was trying to promote in this project, and by extension, with everything that they do. So where we are in the world is along the Hudson River. This is directly opposite of Uptown Manhattan. So this is Manhattan here on the east. We are directly opposite right here. So to give you some bit of context, this is the George Washington Bridge. This is Fort Lee, which of course is a little bit more built up on the western side of the bridge. And then Washington Heights and Inwood and all the great neighborhoods of Uptown Manhattan are over here. This is Fort Trium Park, where the cloisters are. If you are familiar with Uptown Manhattan, that's an amazing place to visit. It also happens to have a perfect view of our site. So I'll get a little bit into the history as we go through this, but needless to say, there was a lot of attention paid to this project in the public because of its potential visibility along the Hudson River. There was quite a bit of sensitivity to it. So that's where we are. It's a terrific site. What obviously isn't evident in this aerial is that the site itself sits about 500 feet above the Hudson River because of the Palisades. The Palisades, as a geological formation, runs continuously along the west side of the Hudson River, and this really sits right above them. The only thing separating us from the edge is the Palisades Parkway here. So just some brief Some high-level stats for the project. It's a 27-acre site, 350,000 roughly of programmable space in square feet. Total construction is 680,000 square feet. That, of course, includes all the parking and any other ancillary functions. It's day one, about 1,000 employees. That is flexed up to 1,500 under full capacity. The program is primarily office space, but it does include a multi-purpose and town hall space, a fairly significant cafeteria with a servery, product showroom where LG can display its latest and greatest products and technology. It has a science hall, which is an education facility that serves really local schools. They can come here and visit and learn about some of the newest technology. There's a fitness center and there's plenty of outdoor amenity space. It's about 1,170 parking spaces, a whole lot of photovoltaic cells on our rooftops, about 2 acres of green roof, 6 restored wetlands, significant reforestation, and it was a LEED Platinum certified project. This is the site plan. Now I've rotated things here to fit on the page. You'll see that north is sort of up and to the right here. And you can see first thing that the site is a little bit awkward in shape. It's kind of triangular. We did have designated wetlands on the eastern most portion of the site. So this was pretty much off limits, and we had to maintain that area as well as the south area. And here there were a couple designated spots of wetland. On the western edge, this became what became essentially a large setback for our development, to buffer our development from the neighboring residential community to the west. And then the building itself is really comprised of 3 primary components. So this is the building right here. There are 2 wings, the south wing and the north wing, and those are joined in the middle by the cube. So as a diagram, as a partee, it's really that the office space is distributed between the 2 wings, and then the cube really serves the more public-facing functions. So like the entry lobby, that science center, or the town hall, conference space, those sorts of spaces really happen in the cube. And then at the north side is our parking garage, and we've made every effort to kind of sink this parking garage into grade. And there were other reasons, of course, which was to keep the height of this building down. Again, as I mentioned, there was a lot of sensitivity about the height. And all of this building was located in such a way to result in a central open space here. It was really important for us to establish this as a campus for LG. So not only thinking about the architecture and connectivity within the building, but also thinking more broadly about how the site can support this idea of a campus where people can really fully experience the development both inside and out. And here's a shot of the building from the north. You can see Manhattan in the back, and you can kind of get a sense of the relationship of the building to the tree line, to the canopies of the tree, of those trees, and then broadly or across the river to Manhattan. And you can sort of get the sense that we have sunken this down a little bit out of sensitivity for the view sheds along the Hudson River. Here you have the south wing in the distance, the cube, and then the north wing. Again, really the office space is concentrated in those wings. And then in the foreground is the parking garage. You can see that's a lower scale structure, and that's entirely covered with photovoltaic cells. In the middle is our central, what I would call kind of a quad space, a lawn space. It's meant to be open, flexible, and actually allow the entirety of the LG workforce to be outside when there are certain events. You'll see this courtyard here. There was a kind of a last minute addition or I should say a reintroduction of a fitness center. And there was a notion that was just put out there kind of by the client almost informally, well, why don't we just put it in the parking area, which happens to fall entirely under this open space, and actually it carries all the way down to the south portion of the building. This is all parking. So we in fact did that, but the idea of putting a fitness center in a parking garage didn't sound so appealing to us. So what we did is we carved out a courtyard immediately adjacent to that fitness center to bring light down there. But it also secondarily did something else, which was provide a really great linkage from the parking garage. You know, most people are arriving by car to the building, so that one didn't necessarily have to just get out of their car and enter an elevator and go up to the office space. They could actually engage with the central open space of the building, walk outside, and then walk right through the front doors and actually enjoy a little bit of the outdoors on their way to work. So talking in terms of overall site sustainability strategies, we did significantly reduce the amount of impervious area as compared to what was here previously. What was here previously was a single-story office building, and it was just surrounded by a sea of asphalt. So we took that and greatly improved what could happen on this site in terms of permeation. The second point I really want to call attention to here is right-sizing the project. And this is a significant sustainability strategy that oftentimes we don't think about, and it's something that if we're really doing our jobs and really being critical about the tasks that we're given, just fundamentally starting to question some of the assumptions behind the program can be of great benefit to our clients, and ensure that we're building the project that should be built. So we came a little bit roundabout to this right sizing, I'll admit. This building started as a 500,000 square foot building. And the metrics that went in to determine what that 500,000 square feet meant included, full cubicle spaces, lots and lots of private offices for LG employees. It was a great amount of the ratio of private offices to open workstations was very heavy. And it assumed that workers were here all the time working, and a whole lot of other assumptions that frankly were just a little bit antiquated. So there was a time early in the evolution of this project, I mentioned sensitivity to the height of this building. There were some environmental groups out there who we started to engage with, started to push back a little bit, frankly, on the height of our building. This originally had been an 8-story building. And frankly, it took some time to work through a process with these environmental groups, working with LG to closely examine their program and see actually what was more realistic for them. And we were able to make a strong argument that they really actually didn't need all of the office space that they thought they needed. We were able to, first of all, bring the number of workstation spaces down fairly significantly. Their workforce was changing. It was a little bit more transient. It was relying much more on part-time work. So that meant that not every employee necessarily needed a seated position. There was also a greater need for collaborative spaces, a much greater need. So we looked at that. So all in all, once we reduced this building by a good 150,000 square feet, it really didn't represent a huge impact to the amount of employees this could accommodate. We did have to make reductions in other areas, but nothing that really fundamentally sacrificed the idea of this project. So that's a key sustainability strategy, just right sizing the project right there. It may not count toward any certification, but just doing the right thing. It's a big deal. Other things, I'll move quickly through this. Again, the building height was adjusted to limit the view sheds along the palisades. We were very sensitive to the depth of the existing bedrock to limit the amount of excavation and blasting required to achieve our below grade parking. Significant restoration to wetlands and reforestation, the addition of 1,500 trees across the site, many of them large and mature, 1.7 acres of green roofs, and really using the whole approach to site planning to allow buffered views of the project, backing our building away from the residential neighborhood, and using this idea of reforestation that as an opportunity to provide some appropriate buffers for views and light against the neighborhood. Site lighting, kind of par for the course, but using photometric and timing controls and shielded fixtures to minimize glare, and just locating amenities close to one another and other kind of key entrances to the building so that we could ensure that they're being used to their fullest extent. And then altogether a 96% reduction in potable water use by irrigation for low demand, irrigation of low demand native vegetation, high-tech controllers, I'm just reading, drip delivery and moisture sensors here. This is a diagram actually from our original competition. This represents the footprint of the building that had been there. And you could see the extent of the parking around that building. So aside from the end, the eastern end with the wetlands, as I spoke to, in areas along the south there, along the Palisades Parkway, it was really mostly asphalt. And then we like to show this diagram on the left is before, on the right is after. So it's a much more green, much more pervious site. What really did a lot of that lifting is burying the parking below the building. So the building is pretty much these two wings that are sitting on a plinth parking that is sunken down into grade. Some details here. I spoke a little bit about that courtyard that brings light down, but just organizing the building in such a way where there's a direct connection from the fitness center, which happens to be in this space, fronting onto this courtyard, allowing that to be adjacent to this outdoor seating terrace, which is directly adjacent to the cafeteria and the main entrance for the north wing. Those kinds of adjacencies we found really meaningful. And just a shot from above of that open quad space. Over here on the left, now, of course, a project of this size will trigger some stormwater management. We had to retain water on this site. So this is just a basic retention pond, as you would expect something of this scale to have. But we really made great efforts to plant that retention pond day one so that it was responsive to the local ecology. We could have easily left this as unplanted or just a simple lawn around it, but we really tried hard to feather this back into the landscape. So that is actually a brand new detention pond that you're looking at. I know you're excited about that. And on each one of our wings in the central image, we did create arrays of PV cells. Otherwise, they're covered with shallow green roofs that seed them there. So we have areas of deeper green roofs, other areas where they're a little bit shallower, where we're constrained by structure. You get a sense of the kind of character of the ground floor. This is all above the parking deck, all this green roof. Just a shot during the planting season of some of those larger caliber trees. This is along the south portion of the property. And when we start talking about the building, energy-wise, we were at about an EUI of 44.5, which is a 60% reduction off its benchmark. So pretty good. Now I'll go a little bit into detail how that was accomplished. And spoiler alert, it had a lot to do with the PV cells. The building massing itself, we worked really hard to keep the massing slender. So we're talking about a floor plate that's no deeper than, say, 95 feet or so, which meant that we could bring in more natural daylight into those deeper portions of the space, so we could rely a little bit less on artificial lighting. The envelope, it's a unitized curtain wall. Even unitizing the curtain wall has sustainability attributes. I mean, it really helps control the quality of the fabrication, ensures consistency in the seals and the gasketing of the glazing in each unit. So there's a lot to be said in limiting air and vapor infiltration. Of course, we had exterior solar shading fins. We used those on the key facades where we were encountering a lot more solar radiation, but also secondarily as bird deterrence. That was a big concern of ours as well. It's an all glass building, so it had to be. High performing insulated glass units, nothing extraordinary, but it's basically double glazed IGUs, triple silver coatings. They were argon filled. And in areas we did have ceramic frit, both as a bird deterrent strategy, but also to cut down on some of the glare. And in areas there was a strategy involving thermal buffer zones, allowing some passive solar heating, and that was in very specific areas. And then, of course, bird deterrent glass. The mechanical design included a water-cooled VRF system manufactured by LG. So it was a little bit, components of that system were a little bit kind of handed to us. So we worked with it. It was a two-pipe closed loop system leveraging efficiencies from the cooling tower, heat rejection, high efficiency condensing boiler to cool and heat that system, and did have a dedicated outdoor air system with energy recovery. I'll show you a little bit of that in detail. I think it's coming up in a slide or two. The garage included demand control and natural ventilation. Did have occupancy sensing LED lighting. Of course, it had EV charging stations. The rooftop PV cells produced 954 kilowatts on-site generation, which amounted to 1.5 megawatt hours per year. And that, according to the design metrics, generated 30% of the building's total electrical demand. And that, when combined with commitments to purchase green power, from renewable sources, that meant that this building was 100% generated or electrified by renewable energy sources. The water efficient fixtures, 34% savings over the baseline. And then, of course, we had cooling towers providing chilled water. And some mechanisms there to help manage the amount of water for makeup water, and also some of the chemicals used to reduce corrosion and other growths within the systems. So keeping those really at a kind of a minimal, manageable level. And of course, high albedo roofing and just green roofs to limit the amount of heat absorption. Some shots of the building.
Hey, John.
Yes, sir.
Yeah, let me just
Brian.
jump in. This is Brian, yes. So for folks that might be interested too, can you go back just one slide on the VRF system? I don't know if you had mentioned this earlier, but the LG manufactures their variable refrigerant flow units, and they were very interested in using those in the project. And this group might be interested in just hearing the type of system that was used there. Typically these VRF systems are a little smaller, but their system actually went up to 42 tons. It has a capacity, and I know different folks have asked about electric systems, heat pump. VRF is essentially an electrified unit. and they were their data says that they can go down to -22 up to 122 degrees and still operate effectively. Now at that lower temperature, I'm not sure how much resistant heating they're adding to that, but I thought some folks might be interested in that. And then one other aspect to the VRF is that it's one larger unit, outdoor unit, that can supply a lot of indoor units. And the important message there is that you can get some good zoning, which, as we know, is always challenging in buildings when you have one large unit that may be operating in a variable manner. But to have smaller units that can, cycle on and off and be more responsive to the demand, can add to the energy efficiency. So that's all I'll say there.
Yeah, and my understanding, Brian, is that the VRF, the units, there was actually one per floor, and these were actually tied into the chilled water loop to provide their, to basically temper those, as well as the high efficiency boilers. So we're getting heating and cooling to manage that loop, and these VRFs tied into that. And then beyond that, that provided the refrigerant to the individual, terminal units. So all of this was LG. Again, it was something that we sort of were given a little bit. There are inherent efficiencies, which I'll cover here in just a bit, but kind of a cool system in the way that it actually resulted. I'm going to jump forward here. So before I get to that mechanical diagram, which I'll show you here in a minute, this is just a couple of different, really fundamentally the two different exterior walls that we had on the project. On the right is that unitized curtain wall. This was an old castle wall, off-the-shelf components. More economically done, designed and built, but still able to integrate a robust IGU and the use of solar shading fins. This happens to be a condition in which the curtain wall flies by the return leg of this curtain wall, and we actually worked hard to insulate even that edge. So there are a number of details in which we really fine-tuned to ensure thermal continuity, I suppose discontinuity, but to ensure that continuity and insulation. On the left is a more bespoke wall. This is really fundamentally a steel wall, I would describe it, AESS steel, that then supports an aluminum cassette system, and then our insulated IGU is glazed within that. And this is the cube. You can see that wood volume beyond. That's the key here. This is a view of our atrium looking from the east. You can see this long projecting prow over it. That gives us the chance to really shade the space. Otherwise, it gets hit pretty heavy with direct sunlight. Another cool thing I just want to point out in this shot is these 5 bays of glazing here. These all act as individual panels that actually raise up, they slide up within the system, within the glazing system, and actually operate as fresh air, makeup air for our smoke evac system. And then secondarily act as just awesome big operable panels that allow us to open up the lobby to this outdoor space. So the lobby can actually flex in size should they have an event and want to use the outdoor space every now and then, they can do that. And just a few other details. This is, again, the photovoltaic array above the parking garage. You can see it's pretty significant in size. And then, of course, our shallow sedum roof at the top of our north wing here overlooking the city. Pretty good views. It was really important for us to take advantage of at each kind of public space to provide as much transparency out to our site as possible, just further reinforcing that connection to the site. And just a couple of diagrams here on the left. I'm not going to go through all this, but just describes our water strategy, pretty straightforward, water retention, water saving fixtures, and in describing the drought resistant plants, the native vegetation. On the energy side, this is what we were talking about with this VRF system. From a fresh air standpoint, we're bringing air in through a heat recovery system at actually the lowest level, and we're blowing it up through the building, and we dump that fresh air into the plenum space above the ceiling. And then at the same time, we have a VRF compressor, and this is a little bit inaccurate in that there's actually a compressor at each, or a condenser at each floor that provides, supplies the refrigerant lines that then feed out to each one of these multi-V units. And when I said there's somewhat of an inefficiency, this is just sort of a lessons learned, kind of to keep things honest a little bit here. But if there's an inefficiency here, it's really in these multi-V units, I would say. They're fairly small. And if you were to look at one of our mechanical plants, there are a lot of these. We end up ducting the air from these multi-V units. But because of the sheer quantity, they're fairly low capacity. It just means for a whole lot more refrigerant line. It means for a lot more fans, a lot more to maintain, a lot more friction in the system. So there is kind of an inherent inefficiency there. That's basically that. This is coupled, as I mentioned, up with a chilled water loop. We have a cooling tower that's integrated into our parking structure. I just want to make sure I am okay on time. Tell you what, David, if I'm running over, just shout, and I can close it up a little bit. This is the main entrance. Just a funny story. We made it about halfway through design, and then the LG, our LG client, they're a Korean company. They opted to bring on a feng shui consultant, and it was determined at that point that our main entrance, which had been naturally on the street side, on the west side of the building, actually should flip to the east side overlooking the river. So completely flipped much of the organization of the ground floor. Interesting development there. And finally, with interiors, 20% recycled content with carpet, ceiling tiles, wood substrates. 23% of the materials were manufactured regionally. 84% of the construction or demolition waste was recycled. Demountable partitions allowed for just flexibility and adaptability. The planning was modular based, again, kind of contributing to that ability to flex in terms of function. Paints, coatings, adhesives, sealants, all of that was low emitting materials. Rapidly renewable bamboo. There's bamboo used all over this project. So that was something that really tied everything together. And generally a simplified material palette. We chose to spend the budget where it really made a significant impact and pull back in other areas so that we still maintained a high quality piece of architecture. And then in terms of health and wellness, there's a fitness center, 3/4 mile walking trail that rings the whole site. There's a basketball court, plenty of outdoor seating areas, both on the green roofs and just the surrounding site. And then the food service itself was to provide a whole lot of healthy eating offerings. And just a few more views. This is a shot from our front door leading up to our lobby and atrium. And in the atrium space itself, we're now in the cube. And what makes the cube distinctive is this wood-clad volume, sort of a volume within the cube. And the patterning on that is meant to kind of recall a traditional Korean basket weaving techniques. And just that communication with outdoors. In a cool moment where between that basket woven volume and the glazing of the glass cube allows for some actual surprisingly private moments within the building. And just a few other details. You can see that steel structure of that facade, and some more details on the lobby. This is a secondary lobby, and you can see how that bamboo is working. The floor plate itself is narrow, largely open office space, but we concentrate the mechanical spaces, IDF closets, electrical closets, and other support spaces within the interior. So that really opens up the bulk of the floor plate for natural sunlight coming through the space. We do have these bands of enclosed collaboration spaces, conference rooms, private offices when necessary, and a large pantry. And just another shot of a typical lobby, our pantry, which overlooks the view of Manhattan, consistently on the west side on the east side, I should say, of the building. So capitalizing on views, and a boardroom which does the same. You can see that bamboo. And if I showed you a before and afters, meaning the existing LG spaces versus this space, what you would notice is a much more wide open, continuous view across the space, but just a lot more light because we're lowering our workstation partitions down, and giving people the opportunity to see other people, communicate with other people, and just open up the space a whole lot more. And finally, our cafeteria space. You could see the wood ceiling, which reprises that idea of the woven basket, and a fossilized living wall. This is plant material that's composed into a tapestry, if you will, that recalls traditional landscape tapestry making. And then our fitness center adjacent to that sunken courtyard, which has yet to be fully fit out. So I used a rendering here. This is my last slide, I swear, but it's interesting to go back to the original competition and see where we've come, and to see which of those features, which of those strategies have really carried through. And I'm quite proud to say that many of them have. And a lot of them, frankly, are just planning principles, strategic planning, and building layout principles and massing principles that are just baked into the design day one. So things like, like the amount of green roof, or the idea of really burying the parking below the building, maximizing the amount of pervious site area, the PV cells, the proportions of the buildings, that all actually carry through. Maybe the idea of using chilled beams didn't carry through, but most of the stuff actually did. So it was a nice surprise for me. So that concludes my portion of this. So David, I think we're limiting questions at this point.
Yeah, well, we're going to do a little Q&A after the next presentation, but this was great, and we have lots of questions that were in the chat that I've got a little Word document queued up waiting. But with that,
Great.
we'll pass it over to Jeremy and his team to present us the outlet project.
Sounds good.
So
Thanks, David. Can you hear me? Everything
can
working
hear
all
you
right?
fine.
All right,
Everything's
great.
working.
Great. Check me on time too. What do we got about?
It's 20 after, so we got 40 minutes. So half an hour in, we'll be 10 minutes left for Q&A. Should be good.
Cool. Sounds good. Let me share my screen.
We're doing all right.
Also, thanks to John. Great presentation. Tough follow-up. Really dug that project. A little bit of a different scale here. So, hey, everybody. Like David said, my name is Jeremy Avellino, and I'm really happy to be presenting again to AIA Committee on the Environment. I run Bright Common. It's a sustainable architecture practice here in Philadelphia, and we have what we think is a simple slogan, and it ends up being a little bit difficult to work out in today's economy, but it's high concept, low carbon for all people. And this is our crew. This was a retreat at the beach on the Delaware Bay shore, pre-COVID. of course, about a year ago. And I had to crack up when I looked at this. It's a bunch of city kids. The city kids at the beach always have Doc Martens and black jeans on, and or like cutoffs rather than like flip flops and a bathing suit. I just love this image. And it's a fun crew. Just so much fun working with these guys. And we're also, it's been a rough year for us for sure. COVID has not been friendly to small businesses, but I love working remotely with these folks, and even safely sharing pods at the office with them too. And it ended well for us, along with this award, which we're really honored to get. We are also, we were awarded the 2020 Philadelphia Emerging Architecture Prize, which is really wonderful. We're thankful and grateful for that. So put together a couple of learning objectives, and that's we want to identify strategies here to achieve passive house or zero net energy performance, and identify strategies for elevated standards for a healthy indoor environment. We'll go over those piece by piece. So I have the conch shell. I tend to be one long run-on sentence if you're hanging out or married to me. But this guy, Jeremy Rifkin, really, he really inspired me about a year ago at the FIAS conference. And when I was down in DC, the last one that was in person, and I just wanted to riff on basically a 5-minute summary of his book, The Green New Deal: Why the Fossil Fuel Civilization Will Collapse by 2028, and the Bold Economic Plan to Save Life on Earth. It's a great read. It's a real tearjerker at the same time. So I highly recommend it. He's a brilliant human being. He's an American economist and a social theorist, a writer, a public speaker, a political advisor to many governments, and also an activist. And he published this book a year ago. And so just a real brief summary. We have, this is sort of information from reading the book, not really my ideas, but stuff that I'm real into. So he says, we've been in the third industrial revolution since 2008. The first industrial revolution was from 1860 to 90, and that was in 19th century Britain. Think, coal, right? The second industrial revolution, 1908 to 1932, and that was, it took about 25 years for us in the US to develop rail, telephone, radio, TV and electronics, the automobile, highways, and that only took 25 years to take on. This revolution peaked in about July 2008 with the financial collapse, and his thesis is that it is now over. We have entered the third industrial revolution. Are things better since the first industrial? Well, 45% of people around the world are in poverty. 55% of the people are doing better. So there are some good things, but here's the inequity. The 8 richest people in the world are equal in wealth to half of the humans on the planet. So you have 8 people here and 3.5 billion people here, and they have the same amount of wealth. And that is far worse than it was 200 years ago. We're living in a dysfunctional economic paradigm. We've built this economy by exhuming 350 million-year-old burial ground and burned the bodily remains to create a fossil fuel-fired civilization. It's been good for a few. It's brought some people out of poverty, but not nearly enough. He gets into climate change and essentially how I think it's good to talk about the rudiments, about how climate change actually changes the water cycles of the planet. We are on the watery planet in the universe. Every 1 degree of global mean temperature change from carbon emissions in the upper atmosphere results in a 7% increase in precipitation in the clouds. And this has led to unpredictable results and weather events. Our ecosystems are not evolving fast enough to catch up with this. And as we all know, we're the 2030 working group, and I know this is a little bit of repetition, but it's important for me to remember this stuff. We have about 10 years to completely transform civilization to keep the global mean temperature below 1.5 degrees Celsius. We've already warmed it to 1 degree since the late 1800s, right? The 11,000-year climatically stable Holocene is over. We are now in the age of resilience, or some would say the age of adaptation. Why do I bring all this up? Y'all know all this, right? But I think it's important to point out that His thesis is this. He's not an architect, but he's pointing out that the only kind of architecture that's going to work moving forward are carbon neutral, high performance buildings or something very much like them, right? And things that are built to the Holocene expectations are simply not going to work very well anymore. Here's 3 things that aren't working according to Mr. Rifkin and 3 solutions. Market capitalism is not working. It's ending. It's too slow. It's entrenched in systemic racism. It simply cannot adapt quick enough to the changes wrought upon it. And he said this prior to 2020. What's his solution? Base the economy on quality of life, not gross domestic product. We need a hybrid of capitalism and the sharing economy. And if you think that's impossible, just look at Wikipedia. It makes total sense. What else is too slow and not working? Well, the internet is too slow and not working. I think we've all found that out this year. If you've done a Zoom call, it didn't work. It's not only not working very well, it's too dangerous. And what do I mean by that? Well, the cloud is slow. Cyber attacks are way up. I don't know if you looked at the news today, but the internet is a dangerous place for businesses and the government, and they're costing companies billions of dollars. Data giants like Google, Facebook, and Amazon are essentially already obsolete. They simply can't even handle all of their own data, which is multiplying by itself. What is the solution? His claim is that a distributed system is harder to attack. And if you've ever watched Battlestar Galactica, you would agree with me, right? So each building is now, his thesis is that in each building needs to be an edge data center as part of a decentralized data grid. I'm going to get to the thesis in a second. What else isn't working? Most buildings, the climate has changed and buildings are also too slow and kind of too dumb in a way. They're designed for the expectations of the Holocene, right? The electrical grid is antiquated and unresilient in the face of increasing natural disasters. So what is the solution here? All existing buildings must be deeply retrofitted. He thinks buildings are at the core of this. And all new buildings must be built to a low carbon standard. Each new building and a lot of homes, he talks a lot about homes, need to be a micro, like a node in a village, a micro power generating site and a transport hub for an electric vehicle. And you could scale that up to buildings like what John was talking about too, right? And I think lots of folks on this call might agree with me. Lots of folks we work for or talk to would say, well, it's not happening. How are we gonna pay for this? This is crazy. And just a few stats and I'll get on with the pretty pictures. Solar and wind power just dropped below natural gas and is way below oil for production costs. Citibank alone is sitting on $100 billion of stranded assets, and that was a year ago. Pension funds, there's $11 trillion of pension funds moving out of fossil fuels, and they're looking for places to invest it, right? By 2028, 20% of EVs will be charged at home, and that's essentially when it's over for fossil fuels because cars, most of oil production is for transportation, right? This essentially is the Green New Deal. Are we going to have it with the new administration? We don't really know. Some form of it is going to happen, and I believe and hope at least that it's going to be thoroughly funded. And I think architects need to position themselves for the third industrial revolution. It needs to be about economic opportunity primarily, jobs primarily, creating a fair and just ecological society, and primarily about the redistribution of wealth. And I believe that passive house, living building challenge, high performance buildings, whatever you want to call them, that these are going to play a core role in the built environment. And we need to figure out how to scale this up so that incoming money can flow into the Green New Deal. Again, I'm not talking about big movements because I'm going to show a very small building here, but I do think that we need many, many, many decentralized moments, many connected small things. Good, we got through the thesis already. Let's talk about the anatomy of what a passive house is. Basically, a passive house is about, continuous super insulation, thermal bridge-free construction, a lot of stuff John talked about, airtight building envelope, high performance glazing, balanced heat and moisture recovery ventilation like an ERV or an HRV. And then we, through energy modeling, we want to design to optimize gains and minimize losses, right? And this can be for an old building or a new building. It can be for a house. It can be for a school. It could be for the headquarters of a major corporation. And it's building science is building science, whether for a tiny house or a giant corporate office park. But we're not talking about a passive house today. We kind of are. It's kind of a passive house. And so we ran this project through some energy modeling exercises and realized that for very small buildings that have poor orientation, it's difficult to get them to function in the 2015 FIA system. And so we ran it through zero energy ready homes, which if you can see my mouse scrolling around, that's this column here. And FIAS is right here. And so if you think about it, you know, FIAS, zero energy ready homes, these are just energy codes. And if you look at IECC 2012 and step it up to Energy Star and then zero energy ready homes and then passive house, it's a simple system that steps up and adds things. I would say we're right in between these two, at the cusp of being a passive house. We just couldn't fit enough insulation in the walls because of how tight this site was. Right. Let's talk about help. This is, I mean, it's pretty much 2020 for me. I don't know, but I have felt like this person adrift at sea, hugging myself. We all need a hug, mostly from ourselves this year, but that's not why I put this up here. I'd like to talk about some just basics. And I think John brought this stuff up a little bit. This is something that you see in survival manuals called the heat escape lessening position. And it's basically a metaphor L. Ron Burrell uses for the way we ought to design buildings. And that's just an exercise in massing and shapes. The more complex a building gets, the more heat loss there is, right? The more your arms stick out in freezing cold water, the quicker you lose energy. It's as simple as that. So hug yourself and allow your building to be as compact as possible. Love this slide here. Yes, we believe small is good, but large projects aren't necessary. They're not small, but they can be compact, right? They can be well designed. It's all about massing, and it's all about getting that heat loss form factor down as low as possible, right? So like the smallest buildings don't necessarily use proportionally the least amount of energy, right? We're looking for shapes that are more like this when you're looking at multifamily architecture or large architecture, you know, larger corporate projects, stuff like that. But when you're getting down, and you can see how different it gets, you know, 4.5, you're just never going to hit the passive house standard. Really, to hit the passive house standard, you need to be 2 or less, generally. And if you think about that, you have a chance before you do any energy modeling. This is a simple back of the napkin calculation, right? So this is a surface to volume ratio calculation that is essentially simple arithmetic. Once you do this calculation, and you can get your form factor from whether it's a chipboard model or a foam model or like a SketchUp model. You can do this very quickly, and essentially, if you can get that below 2, you are guaranteed to really have an easy time hitting zero energy, unless you just essentially make the building all glass, and then it can get really difficult. And then this is kind of zooming in on a much smaller project, right? 2.9, essentially, this is the only one that gets even closer. Oh, I'm sorry, it's under 3, not 2. So as long as you're under 3, you generally have an easy time at passive house. But look how different these long, skinny shapes are. Single-story buildings, L-shaped buildings, more complex shapes. Can it work? Of course you can make a passive house out of these things. But what happens is the walls get thicker, right? Things get more complicated, you know? And so it drives up costs at every step of the way. It has a compounding effect. And if you have a good heat loss form factor, if you're hugging yourself, if the building is hugging itself, it has a lessening effect on cost and detailing and buildability and then maintenance in the future, right? Let's talk about some buildings hugging. This is Philadelphia, this is Fishtown, and this is the site. It's a street-to-street lot right next to Holy Name of Jesus Cathedral in the heart of Fishtown. And it once was 2 separate, it's a street-to-street lot. It was consolidated sometime in the 20s or 30s. They tore the house down that was here, made a 1-story garage, didn't do a very good job at it. My clients bought it, they live here. They tore down the garage and they decided to make a project of their own. So in a sense, this is the street. It's a very small street, feels like South Philly to me, where I was born. And you know, it's a lot of working men's homes, row houses, workaday buildings, and then at the end you have this really grand church at the end of the block there. It was designed by McGinnis and Walsh, and it was built in 1923. The cathedral at the end of the block, and it has some really beautiful stained glass from Philadelphia's renowned the Ascenso studio. So our clients were a young family, and they came to us with a desire to not only deep energy retrofit their existing home, which is in process, but to tear down the garage, which was on the back of the site. This was their existing home over here, and then a one-story garage, which was halfway torn down already, and replace it with essentially what became a hybrid accessory dwelling unit. It's one part income generating rental unit, which is above, right, accessed off the street, and one part client artist studio. And so they're artists, and so they use the back of the space entered through the courtyard as their artist studio, and then one part off-street parking space, which is for them. The design, I would say it's an abstract form of a carriage house, essentially, that takes its cues from the immediately neighboring church's grandiose windows, as well as Philly's vibrant history of urban infill, postmodernism, particularly nerding out with the clients on all the cool buildings in society built in the 70s, all those homes that I never quite understood before and now have completely fallen in love with the older I get. And so this is just me sketching what I see, and my process tends to be I sketch what I see and just let it kind of take me over, and then boil it down to its constituent parts, and then marry it to the site so that there's some kind of connection there from inside to outside. And so what really became clear is that the view of this, the spire and the apse and all the stained glass window was just really wonderful. And so we wanted to create a grand space inside that sort of had this dialogue with that across the street. Here we are. So it's essentially, in terms of its massing, it's a 2-story brick box with the superimposed arch, and that stands in front of a 3-story metal box, this black box that steps aside and back. And we kind of took that as this deferential massing idea. It's akin to like a mansard roof at the 3rd floor, which kind of sits back like this, and we just kind of went like this and set it back that way and had a lot of fun with it. It's nicknamed the Outlet. It had a lot of names. Our projects tend to go through about 10 or 20 names as they go. And the client finally picked Outlet. And we thought of this place in a lot of ways as a receptacle, right? A place to let out, to let out a space, to rent a space. But it was particularly in a context of something we like to refer to as the electric resistance. And yeah, that's a lot of play on words for one sentence. But we don't use fossil fuels as the fuel or power source on our project. Now, electricity is dirty, we all know that, but we want to start with the ability to have the roof have all PV. I'll get into this in a minute, and then reverse engineer the envelope to get to zero energy. And so a lot of this conversation with these clients who generally were unfamiliar but very open to this, to say like, no, we don't have natural gas on the project at all, and had a discussion about cooking stoves and heating and cooling and hot water. And we're just at a point in human history where we do not need to burn that stuff to heat and cool projects. And so we start there, fossil fuel free, rooftop PV, and then reverse engineer the envelope around it. And hopefully it has some cues to its neighborhood. Definitely marrying craft with sustainability. We worked with the builder, Future & Sons, Travis Douglas, and the owners have a really keen eye for finishes and just hiring lots of local artisans to do things like custom concrete sinks and vanities and things like that. Just had a lot of fun. This is that space which we were able to lift the 3rd floor bedroom to step up a few steps. So you have this 11-foot ceiling with this grand arch, which kind of talks to its neighbors. Really fun living and dining space. This is the kitchen, and again, this was originally operating as an Airbnb, and it's a bit of a hybrid space now. I'll get into that in a minute. And some of the spaces that go up to the 3rd floor, you can see this 3-step up here, which allows for a compressed zone in the kitchen and a taller space into the dining room. And again, the steel railings that are crafted by a local artisan. So what is a home? Again, riffing on Rifkin, essentially in the third industrial revolution, a home needs to be thought of as a resilient node in a village, right? And cities are perfect for this. Philly is set up to be a climate change adapted citadel, essentially. But we really need to focus on resiliency within our city, building by building. A home can be a micro power generating site. It's important. Passive house principles allow it to act as a thermal battery, which is effectively the first resiliency tool. So even if you don't have backup, it can act as a power battery too if you have batteries in the house. And this one doesn't yet, but that technology is getting there. It's getting cheaper every year. But essentially, even in the event of a power outage, something we call passive survivability kicks in, where if you know, as long as you're not keeping windows and doors open in the middle of the winter, if there's a power outage, this home will effectively never get below 60 degrees, even if it's in the single digits outside, you know. And so it'll take a week or two to coast on that, where it will be totally comfortable. So that in and of itself is resiliency, right? Throw in a backup battery in there, which we use on some of our other home projects, and essentially you can have an islanded microgrid. You have your own grid. You're essentially off grid. We set up our electrical panels this way with the flip of the switch. The PV then feeds a battery, and you have a critical loads panel, and things like the refrigerator, the mechanical ventilation, some lights, things like that can operate all the time, right? What else is a home? Well, a home is a transport hub for an electric vehicle, right? Electric vehicles are set to take over internal combustion engines completely before 2030, right? And so we want to set up each house to be electric charger and electric vehicle ready, where it makes sense. Not all, this is very rare to have a garage in a city home, and we recognize that. But where we can do it, we want to do it. And then it's also housing has changed in 2020 massively, right? We were all thrust into working from home, teaching our kids from home. And so we want to make homes this hybrid space, if we can design it, where you live, you work, whether, you know, sometimes you have to, sometimes you want to, right? You create homes as an income generation tool and places to recover and heal. So I want to talk quickly through the cross section here. We normally do take a fabric first approach. This site was tough. There was a lot of shading from that church. It did not have ideal solar orientation or passive solar orientation, and so we essentially took a technology approach first. And we basically said, and we try to do this on all of our projects that are in the city, to say, let's leave the rooftop fully free and clear for photovoltaics and see what we can generate there. And in this case, it wasn't a lot. It was 5 kilowatt hours, 5 kW. It was basically a 5 kW system, right? So that's not a lot, not even for a home, not even for a passive house, but we wanted to reverse engineer that into the building envelope to make the walls thick enough and the slab thick enough and the roof thick enough to be able to say, is that going to be enough to hit zero energy, right? What's also important in this cross section, oh yeah, here's our red line. Whenever you're driving, this was a bit of a complicated project in the sense that the ground floor, this is cut through the entryway from the street, but the red line represents the passive house envelope, the high performance envelope. And it's a little complicated. It's a little janky, right? Because the ground floor, this is the art studio in the back, access from the courtyard, and the garage kind of behind the entryway here. All of that is outside the envelope. It's very difficult to make a garage door airtight enough. And with some of the pollutant source control from car exhaust, even when you're starting the car up or leaving, and you know, some of the paints and other things associated with our generation, we just decided, let's just leave that out. That space has its own HRV actually, that can handle some of those contaminants and particulates and it's balanced in a way so that you're never pressurizing that stuff up into the house, and the spaces are compartmentalized from each other. And everything else is our passive house envelope. We put a small rooftop deck on the back, which the clients wanted, but we were adamant about keeping the rooftop free and clear for PV. So let's talk about some lessons learned. There were a lot of lessons learned. This project kicked off in 2016 or so. It's been done for a little while. And it's an urban infill project. So you're building new construction, but you're building directly up against other buildings. And we really tried to mix craft with sustainability. And so I'll talk about a few lessons learned related to specific passive house principles. And the first one is about envelope. And passive houses need to be thermal bridge free. So you can think about that simply as they essentially need continuous, uninterrupted insulation. There's a lot of ways to do this, whether it's a double stud wall or a single stud wall with exterior insulation. It's probably the easiest way. We've played around with a lot of different things over the years. Some we will never do again. This one I thought worked out really well, but it definitely posed some challenges where we had to get into it with the structural engineer about some envelope engineering beyond their normal scope. It was Larson and Landis, and they were just really wonderful to work with, very patient people. But you can see, to create this, let's just say I really cut my teeth with the Brick Industry Association, understanding forces of brick and veneer design around an arch. These are things I've never looked at. I just thought you could sort of build the arch and it would be fine, but you know, the sides are very skinny. So we ended up having to put in a 7" by 1/2" rolled angle, hot dip galvanized, bolted directly to a wooden beam. So it's a hybrid beast, and there was a lot to learn there about. It wasn't a simple detail, and knowing that now, I may have designed it differently, right? Just the aesthetics of it, but it was really fun to work out too. But what you'll see here is a few different things. So in the detail here, you'll see this large rolled angle, and that's bolted directly into this built up wood beam here. But what I didn't draw is the therm model about just the heat loss through this directly into the structure. There's a little bit of insulation here, but it was a moment that I think it was too late into construction for us to catch this. Had I did this again, I think we would have put 2 inches of Armatherm insulation or some other kind of incredibly rigid EPS insulation so you could bolt through that into the wood beam. And we get into that stuff and our engineers just sort of like start to freak out, but we talk them off the ledge. They're generally pretty conducive to it. So I know that we're losing heat through that. Is it a condensation risk? I think it's one that I'm willing to live with. I don't think it's going to rot the building out anytime soon, but it's one that I will, given the extensive flashing here, but it's one that I would do again differently next time. Also, a huge lesson learned is this was our first building with putting bricks, a veneer brick wall, full bed veneer brick wall with exterior insulation. And in this case, we chose mineral wool. It has a lower global warming potential than foam. We generally are a foam-free practice. We really avoid high global warming potential materials. They have that nasty embodied carbon associated with them. Mineral wool is no saint. It's not rigid wood fiber. A lot of our buildings are using that now, but we really do like it for all of the benefits that it has. But we did inspect the brick ties, and the builder was, kind enough to find this really neat brick tie here that has an adjustable cleat that goes up and down and has a multi-stage system that bolts this back to the plywood, which I thought was just a really neat thing. They're about $5 each, so that was a bit of a cost tag. But these are the things that we need to learn about as we're thinking about passive houses and brick veneers and things like that I just hadn't thought about until they actually got into the field. But it was a really fun process to work out. Another lesson learned is resiliency is very important, but when you're designing systems in a building at any scale, you really have to think about future-proofing it, simplifying it, how you're going to maintain it, how you're going to change filters, making it easier to install so contractors and tradespeople just aren't cursing you up and down. And we thought we did. And I learned that ERVs are larger than I thought we needed. The ERV we originally spec was smaller. We didn't need all the CFMs, the one you're looking at on the left there. But this one was easier to install because you could twist it anyway. And essentially ran out of room. It's a bit of an embarrassing detail. But there's an access panel that had to like turn like an abstract piece of art because it was just too tall. The contractor was kind and fit it. But I just think it's a bit of an oops moment. And really in terms of ERV ductwork, even though these Zender units have really tiny ducts that fit in 2x4 walls, and that's all great. Reality is all of these ducts add up to be a lot of ductwork, and you really need to provide drop ceilings essentially almost everywhere to fit this stuff. And we learned that the hard way on this one. We got it all in, it's functioning, it's commissioned, it's working, but it was really a headache fitting all that stuff in there. The image on the right is the sump pit cover, which you know, it was before we had a detail for this. Now we have a lot of details making airtight sump pit covers, right? Which if you buy one, they're about $4,000, and that was not in the budget. So the contractor, I don't know how he did this, a wonderful human being, a craftsperson, and a good friend of mine, and he crafted this precast custom concrete sump pit cover, which I can't imagine what that's like to get off, but it's beautiful and it works and it's airtight. The blue tape was a temporary thing. And then on the bottom right is all the stuff in the garage, you know, between the meter sockets, the inverters, the large panel. You're going to need a 200 amp service for any house that's all electric, fire sprinkler equipment. It's just a lot of stuff, right? And I'm thankful we had a garage because we didn't really think this through. And now what we don't have here yet are batteries, right? And where's the electric car charger going to go? Because we, you know, when that happens. And thinking resiliency through, future-proofing it is incredibly important because urban homes have like less than zero space. In the burbs, it's a little easier because you have a detached garage usually and things like that. So you don't have to really, really fully think it out. But in the city, you really got to think every step out. Retrofits are even harder. Right. So, well, you know what? Let me just go back up and just talk about one thing that's I'm really excited about with the ERV, and that's COVID-19 kind of sprung so much upon us, but there's a lot of talk in the industry just about how much more important it is now to have homes and offices and buildings that are spaces where high indoor air quality really. We need to be in spaces that are about healthy living, that are about healing, that are about recovery, right? And we can get, you know, and I'm not going to deep dive into like HVAC systems that like actually kill pathogens. That's not necessarily what an ERV is, but with continuously refreshed air and filtered air, enthalpy recovered air. I live in a house with an ERV. I can tell you it's wonderful. The level of indoor air quality is superb. And I think that that's really important as we think about equity and when we think about access, think about agency, we think about health as a basic human right. This is the kind of housing that we believe is for all people, right? And one of the things that's really cool that clients did is once COVID hit, they had been using it as an Airbnb rental income property. And then they switched over and said, essentially, they're going to open it up to, and it's been this way for a while, for months, where first responders, particularly nurses and some doctors can stay if they think, you know, if they think they've contracted or they have and they need to quarantine, they can stay here for 2 weeks at a time, and then it's clean before the next person comes in. So it's been a recovery space during COVID-19 as well. And yeah, leave it at that. So let's wrap it up. So essentially, how's the project been in operation for about 18 months or so? It's always a fingers crossed moment, you know. It's been operating really well though. It's actually been operating at net positive energy with a full rental schedule or occupancy schedule, if you will. So that's really great. It came in at a HERS 14 on the Zero Energy Ready Home. Uses the HERS rating system, the Home Energy Rating Score, and you know, a 0 is like a model net zero energy building. So this one is actually doing it's modeled at 14, but it's actually operating below zero, essentially. The builder is Scott Travis Douglas with Future and Sons, just an absolute gem. The rater was, I'm sorry, that's DSB Energy. It's a misspell on my part. David Berg, just really wonderful to work with, very iterative process. Larson Landis was structural engineer, and I didn't get a chance to fill in these before we were done, but the house is about 1,800 to 2,000 square feet, and the second and third floor are the dwelling unit, and the first floor is the garage and art studio. Construction costs hovered about $200 a square foot from what I can remember. And that was tight. You know, I think if we built it again, we could use a little bit more money than that. Again, it's a zero energy ready home certified project with the Department of Energy. It's a great program, very akin to Passive House. HERS 14. Air tightness came in at 0.7 ACH 50. Again, sorry, I didn't get to finish filling this out before we started, but the slab, the walls, and the roof, you know, frankly, they're all about 20, you know, 10, 15, 20% better, more than code. It wasn't like a radical departure. Air tightness and handling your ventilation losses is almost everything. So Passive House has, and I think if we ran this through BS 2021, which is actually coming out with a prescriptive checklist now for single family homes, I think we would be very, very close to hitting their metrics without even having to do a detailed energy model. So the system's really changing. It's getting easier every year, and I really encourage everyone to look into it. Windows, we're not triple pane windows. That is what would really kick you into Passive House for a project like this, but we did have really nice Marvin windows. Heating and cooling, just like every project this scale, it's all air source heat pumps. ERVs, we almost always go with Zender Comfo Airs, but we've been also looking at Panasonics and Zimbrones. There's a lot more out every year in that. And domestic hot water is a 50-gallon heat pump water heater. And the energy, the PEUI metric is 5.5 kilobTUs per square foot per year. So through energy modeling, we were able to identify, you know, we really don't need triple pane windows in this project. You know, they're very, very expensive, very hard to get. And at a certain scale, at a certain cost, it totally makes sense. And Pell is coming out with some this year, so it's becoming more accessible. But for this, there was a point of diminishing return, and we said, you know, I think that's enough. And again, it's operating as we expected. And this is the project. It's a fun project. Really wonderful clients, wonderful team, and yeah, I think that's all I have to say. And thanks again for having me. It's great.
Thank you, Jeremy. This is great.
Is that you and your kids?
That is my kids.
Yeah, you might recognize that guy.
Did you pay them scale?
I mean, yeah, they were modeling that day. That's the kids and a neighboring kid, but that's effectively a real scene, you know. That's the real Philly life right there, Brian.
Great.
So we're just about at time, but as long as everybody's, you know, willing to stick around with us, you touched upon some things, Jeremy. I wanted to sort of tie into a question that Bunny had posed back on the LG corporate headquarters piece as well. Bunny, you were asking on that particular project, did they study triple pane glazed IGUs during the design of the project? If so, were there any lessons learned on life cycle cost of double versus triple pane? Any advice on advocating for triple pane glazing with the client? And I'd like to sort of put that that type of question to both of you in regards to evaluating components of performance and how you bring that forth to the client, how you sort of rationalize or bring to them the sort of cost benefit or the variety of types of benefits that could be played out, just how that conversation goes and how you sort of bring information and data to the client to help make informed decisions.
Well, David, I could speak to on the LG project. I think we did do value.
So it's meant to be.
We did a cost comparison basically, and it's always a return on investment, at least in when we're talking about a commercial client who's doing a development like this, and it just comes back to, does this make sense as it costs day one? I think in our case, the triple glazing, whereas obviously you get the return on the performance, it had other sort of externalities that were associated with it. I mean, it's a deeper unit. It's a heavier unit, obviously, so it has a kind of a trickle down effect into the framing of the curtain wall. So there were other kind of associated costs that came with it that made it a little bit cost prohibitive, at least for our client. At the same time, since we had an energy model, comprehensive energy model to show energy compliance, we were able to leverage that and illustrate the sorts of savings that they could see in terms of energy consumption. But again, frankly, it just came down to cost and kind of the particular circumstance of our project, in which we were looking at a significant cut in program, as I mentioned. There was an associated cut in cost in the budget that was disproportionate, actually, at that time, and we were really kind of scrambling to make that old castle wall really, frankly, as sort of as straightforward as possible, while performing at in the best light as it possibly could. So that's how we ended up with the double glazed IGU, which in and of itself was actually a pretty good performer with its triple silver coating and argon and fritting.
To build on that a little bit more, there was another question somewhat related. During the design, did you all consider other types of exterior assemblies at any point in terms of reducing glass areas, size of the cooling system, glare on the interior? Was there other types of envelopes that were studied as part of the design process with this?
Yeah, I'll be honest, David, much of the design, at least the fundamentals, kind of predated my involvement. It was such a long project. This was 2010 when we were still designing glass buildings. I have to say, as a personal personal goal of mine is never really to design an all glass building. But here we were. We did, of course, look at areas of other materials, most notably metal panel rain screen, and we do have a bit of that, just plate metal rain screen. But I also saw there was another question. I think, Bunny, you may have asked this. The potential of a double skin wall, and maybe that was in the context of the cube. That was something we didn't look at because, again, the idea of this all glass cube with this volume inside was something that was kind of baked into the original competition. One thing we do try to avoid is putting ourselves in the position of having to solve problems of our own making. So again, in that case, we designed a single wall, albeit as efficient as we could possibly do it. But we just knew that a double skin for our client would trigger other issues with us.
And Jeremy has a question here, which actually builds upon a question that I was thinking about myself early on, as you were talking about sort of the efficiency efforts on this particular project and switching from enclosed offices to open offices. Just thinking about all those things and sort of the current COVID issues that we're all sort of grappling with. Jeremy's asking, if you guys had looked at the high indoor air quality principles within LEED Platinum as a sort of potential bonus within the sort of post-COVID world we all live within. And I was also curious about how sort of subsequent conversations might have gone with the client now that you've sort of made the building more efficient. People are sort of sharing these open office environments, which is more sort of the standard for offices over the last several decades. But just how that conversation, or how indoor air quality and sort of post-COVID conversations have unfolded for this project.
You know, in terms of the indoor air quality and amount of fresh air that we're dumping into the space, Phil, I don't know if you're still on. Do you have any sense of how? Do you have a sense of what we looked at in terms of quantity of outdoor air and just other ways of improving indoor air quality aside from materials that we're using?
Well, not specifically. I mean, in regards to the question, it's an interesting one, and unfortunately, you know, we had wrapped up construction, or wrapped up our effort right as COVID was coming online. So I know that LG, throughout the entire process, they pushed certain values, and indoor air quality was one of them. So I know that inherently they see the benefit of it. How it relates to a post-COVID world, I think, is a great question. I think it's something that we haven't really had a conversation with them about. I don't know that we fully have absorbed or know how the strategies we employed is going to benefit them in that regard. Just being honest.
Oh,
John, you're on mute.
Sorry. In terms of workplace design strategy and the effects of COVID, I think, again, it's a little too soon to understand how it's best for clients like LG to properly respond. I think, yes, we can look at a project like this and we can say, okay, in certain areas, we actually made a more denser environment. We're looking at more collaborative spaces. We're looking at potential for different people to be using the same workstation areas. I stand by all of those strategies in a non-infectious disease pandemic kind of environment. I think the fact is that COVID is going to force us to rethink not only these environments that we're creating, but just the sheer way that we work, which we're already starting to understand that we are able to work in more ways than just being all lumped in together under one roof. So I think the jury's still out. For the moment, I know LG is going to space out every other workstation. And fortunately, they have a building that can flex with their use. They could even lease out half their building if they wanted to. It's a pretty flexible space.
all right.
Just going to say, John, at that point, sorry, David, if you don't
Go.
if you just like a one or two sentence answer, it's so interesting. If you were designing this building now, do you think it would be half the size? Just a gut check, you know what I mean? Like if there's only half the building going, or like what are we looking at for offices? Just like everyone spread apart. I know that we're going to solve this, but
you can't. Nobody can pay for having the density of office space, especially immediately outside of Manhattan. It's just nobody's going to go for that. But a more distributed model of the workplace, I think that's a real possibility in the long term. There's always going to be a need for consolidated office space for places where people do come together. But I think this is going to put real pressure on our work habits, our work life in general, and frankly challenge the 9 to 5 pattern of commuting to work every day, being under one roof, and then going back to your place of residence. I think it's going to kind of start there. If I were to design a building now, given that program, well, I would start by right sizing it, but also encouraging our client to really think seriously about how transient and flexible this workspace, this virtual, in the biggest term, virtual workspace can be, and how they can leverage it. Frankly, they can save a lot of money on commercial space.
Well, and Jeremy, you also spoke to the resiliency of the distributed node. and at the beginning of your presentation. I think
Yeah,
a lot about
and
that when it
Rick,
comes to like the electrical
about-
systems and.
Yeah, sorry, David, I interrupted you. My bad, man. I'm just thinking about that your project is really noteworthy, John, in the sense that like what houses are changing, everything's merging, but how do we design this back and forthness in a new way? Do you even, do you cut the parking spaces in half? It just makes me think like we don't know, right? It's just your project is making me think that because these kinds of buildings take so long to complete, where this little house took a couple of years, yours taking so long, and that's normal, and the world just changed in a heartbeat. So how do we begin to protect the future? And I know there's no answer, but it's just making me think about it.
Absolutely. Yeah. I mean, it gets me thinking about how we can utilize our spaces just more effectively. I mean, when you think about it, we're using our houses so much more efficiently. They're no longer sitting empty. Of course, our commercial office space is now. But it's interesting to think these newly found efficiencies in our architecture these days. I think there's some lesson there. But you're right. This project has one foot in a decade ago and another foot in the upcoming decade, and it does prompt a lot of thoughts about how we can potentially do things better.
All right. Well, that's a great way to conclude this. I'm going to hand it over to Bunny. She's got one thing to talk about before everybody wraps up and heads off to dinner or whatever's next on your evening. 2030 commitment.
Yeah, I'll keep it short. Thanks everyone for hanging on the line tonight and for a really engaging Q&A. Great presentations too. Thank you so much, Jeremy and John. This concludes our first year of the 2030 Working Group in Philadelphia. It's been a really incredible experiment with everyone on the line, and we've had tremendous turnout and also engagement from across the country. And we are looking forward to doing this again next year. We're working on pulling together the topics and figuring out what can best serve folks in Philadelphia and the greater AIA community. And we have a quick survey that we'd love for you to take so that we can get some feedback on how we can support firms in becoming 2030 signatories or in reaching the targets to become to design net zero buildings by 2030. So I'll drop that in the chat, and if you could take 5 more minutes out of your evening just to complete that, it would really help us in the planning efforts for 2021. And thank you so much. I hope everyone has a happy holiday and wonderful new year.
Hey, Bonnie.
Hi, Marjorie.
Hi, I couldn't tell. I actually am not familiar with how to speak back on this. Sorry about that. I'm on a smartphone. Is this speaking to everyone or just you?
We hear you.
To everyone.
Oh, that's fantastic, because you guys, it was a great presentation. I'm thrilled because it was global in many levels. I like the dichotomy of the 2 size projects. I wanted to just share a comment for the large LG project. It is large. It reminds me of when laboratories were being designed because they could never keep up. And it was even back to Louis Kahn designing his laboratories. He would design them to be flexible. So maybe that's just a notion. It's not a design. It's a notion because the world is always changing. Just a thought. And then back on the 3rd industrial revolution, incredibly thought-provoking. How can that interface with climate change with our new administration? Kind of an exciting thought, because here we have new leadership for climate change. John Kerry in charge of that. How does the 3rd industrial revolution, and then more specifically, more on a different scale, the Committee on the Environment and Architecture, because buildings are such an immense use of the energy. How does that get addressed or something? Just opening.
Well, Marjorie, have you
Thank
read?
you for smiling.
Marjorie, have you read the Biden climate plan? I mean, it's essentially like a light version of the Green New Deal. It's actually really encouraging.
Yeah.
I personally think it needs to be ramped up, 5 times the amount of money they're putting towards it, but it has all of the points. It's like a zero energy ready homes. It's like an Energy Star home versus a
Right.
passive house, and it needs to be funded to be a
Well,
passive house.
that's just it. We've had great plans. I'm actually been living in Wilmington, Delaware, so I know Biden. I rode my bicycle down to hear him and Kamala Harris speak because I just was compelled, of course. But it's how do they get implemented? Because it's the ideas, yeah, and it's a plan. How do you fund it? I mean, it's really big. It's an enormous notion. It's just an enormous notion because it's buildings that are being built all around the world. At least now we're part of the global conversation again. I am implying a lot. I can't help it. Can't help it. But it's good. It's what do you call it? We have a lot to look forward to and be hopeful for right now. That's another way to look at it. It'd be interesting to see how, whether you're saying Biden's plan, or let's just say climate with the United States, but how then on the level of the architectural firms, how, and we're not the owners of the buildings, we're lucky to be designing them, but how it's part of our municipalities, just the whole public policy to have them implemented. We all have the great ideas. It's how do we, how can they?
Yeah, we've had these ideas. Nothing I said was new. I don't think anything John said was new, right? Like we have the tech, we have the thinking, and what we don't have is a society that wants it yet. And but that society is kind of coming, right? I feel it coming, you know, in a way.
Yeah, it's been coming for a long time, actually. That's what's why. And I'm saying that, and again, I can't help it. I'm so glad to hear people laugh. Thank you for laughing too. I'm looking at you because I have to say I've heard these conversations for decades, and but maybe that's just part of life. I'm so glad to see you. I'm looking only at such a small thing on thank you again, because we've been through these conversations, but at least we now have the leadership that is ready to have the conversation and not go backwards. So I don't mean to be against the other side, but because Republicans can care about the climate too. So I don't mean it to get into the politics that way, but it's interesting how to have them, whether it was urban planning or whatever, but there are times throughout history when they became part of the whole public policy. It's such a big scale, but I really enjoyed tonight's presentation. Glad I chose to log on and all of those things, but it was great to have the dichotomy of the two size projects. There's something pretty awesome about that because it's thought provoking. And it's at all scales, and it goes right down to the details.
Well, Marjorie, it seems to me, and you know, it seems to me we're at a moment. You know, we've all had the ability to sort of reflect upon what's going on around us because we've been quarantined. We haven't been able to distract ourselves by, you know, whatever it may be, the Eagles game, which isn't worth watching, but it just feels like, you know, it's not just the Committee on the Environment, but when I look at what's happening within City Hall, I see young Black legislators pushing for the new Green Deal and for equity and for social justice. And you have similar conversations happening within the state of Pennsylvania with Reggie. And not to say that, you know, we've solved it or we're headed in the right direction, but it does feel like, you know, it seems just undeniable that we're in a moment where there is a climate crisis. You know, California, Oregon, Washington State, Canada, you know, is literally on fire. You just couldn't like look away from it. And it just feels like
Australia.
And Australia. Yeah.
It's global.
Yeah. We're not just saying like we don't have enough data yet. Maybe it's caused by humans, maybe not, but we just don't know. It just feels like we're at a moment where it is undeniable, where the conversations are happening in so many different circles that, you know, I didn't grow up, well, born in the 70s, but I didn't grow up in that moment. But when I read about how someone like Nixon passed the EPA because of what happened in the 60s, it feels to me like we're in a moment like that, where there is just sort of this building of momentum behind this that we just have to keep at it. And Biden's got the sort of, you know, light version of the new Green Deal, but we have to keep pushing. We have to keep at it that we need more than that. And we need to be operating at the local level and at the federal level and at the state level on these things as much as we can, and trying to find where, you know, we can have collaborators whose needs align and overlap.
And
We're
I'd like
not-
to add one thing to that. You know, our theory of change in the co-committee is that we sort of approach this on from all different angles. So we have a policy and advocacy committee that tracks national policy, but really focuses on state and local policies. And right now we're working on efforts for the regional greenhouse gas initiative, RGGI, to be passed. And we're doing advocacy work with the state legislature for that. And then up next, I believe, is some work on trying to get a zero code adopted in Philadelphia. And if these are things you're interested in being involved with, we'd love to have you join the efforts. Brian, who is on the line, but may have had to step away for a minute, is our fearless leader and policy expert. And it's just been really great to see the work of that committee this year too.
Awesome. Thank you, Bunny.
I just want to add one note to Marjorie's point about smiles on people's faces. Jeremy obviously talked about Jeremy Rifkin earlier too, and one of the biggest takeaways I have from that book was he talks about the idea that doomism is just as powerful or maybe more powerful than denialism. So I think that's something we need to keep in mind every day when we wake up to do this, is we need to take this very seriously, but we also need to like have a smile on our face while we're doing it. And it just can't be something that we feel overwhelmed by. You know, it's really hard to do, but it's something that I have to continuously remind myself, is that I have to be lighthearted about this, but still like adamantly serious. So thanks, everyone.
Okay.
This was great.
Yep.
All of it.
Yeah, man, this is so healing. These spaces are so good for me because I really, when you look at if you just look at the data, it is doom inducing. And it's tough because we're all alone in our spaces now. So as weird as Zoom is, it's really healing for me to be a part of a community that engages like this. And, you know, I think that, you know, we're facing we're in a difficult time. We're facing more difficult times. We're not out of the woods by any stretch of the imagination, but it is very good for me to know that I'm doing it with people and to see a broad range of projects and to have a consensus approach and all that. It's really good. So I'm thankful for this group. Really, David and Bunny, all the work you're doing this year. I'm just so thankful for you guys, all the work you put into this, the personal time, just like a huge thumbs up. Thank you.
Well,
We
the
have a whole
quarantine,
band of
the
leaders.
quarantine has like allowed us to connect to so many more people outside of Philadelphia,
Good.
and see that, yeah, we're working towards this as a collective.
Because no one
I'll
can do it
say-
alone.
Jeremy, you had your Michael Phelps moment the other night, you know, with all the awards you were racking up. I hope that's an indication of you're gonna wear all your chains around your you know.
I don't know, dude. I don't have the Michael Phelps body, so I can't hold all the gold, you know?
I'm telling you, they
It was a
kept
nice
rattling
moment.
the name off, and you know, it made me really, you know, I don't say proud. I don't take any ownership of what you're doing, but you know, to know that sustainability drives what you do, and that you are, you know, really racking up the awards, to me was just fantastic, and it's really an indication of where things are going.
Thank you, Brian. I appreciate that. Yeah, thank you. It was a nice moment for us.
All right. Well, so everybody, we've got our monthly Committee on the Environment meeting this Thursday morning at 8 o'clock. So if you can, join us then. Otherwise, have a great week and restful holidays, and we will see you in the new year.
Yeah, thanks
Yes.
everyone.
Happy holidays, everybody.
Thank
you.
you. guys.
Yep.
Thank you to
Bye-bye.
John, and thank you, Jeremy,
Very
your
welcome.
teams,
Thank you. Thanks
everyone
for
who
having
made
us.
those
You're
projects.
welcome.
Good night. Thank you.
Thanks,
Hey, guys.
Marjorie.
And thank you, Marjorie.
You too. That was awesome. Thank you again.